So we're going to basically drill and tap these two holes. So let's go to drilling. We're going to drill. And we're going to select our tap drill from the UMC library for the 1032 tap, which is our 177 thousandths drill bit. We're going to select that, and then we are going to go to multi-axis, and we're going to set our tool orientation. So this is our first 5-axis move, and we're going to select our z-axis is this plane here, and our x is still to the right, so that's good. We're going to go to geometry. We're going to select our two holes. And right now it's going to default to not going deep enough on those holes. We'll put them in order by depth. We're going to go to the heights. I'm going to go ahead and leave stock as the top because we're on the side here and we do have some material there, and a little more conservative. But our whole bottom, we definitely want to break through so that the tip goes through. And then we need to go a little bit deeper to make sure that it cuts all the way through the hole that it's going to segment with. Now the first few teeth on a tap don't actually cut anything. We don't want to hit bottom. We've got this breakthrough tip. We want to go a little bit farther. We're using a 1032 thread, which means if we are going to have the drill bit go, say, 4 or 5 threads deeper, it's 1 divided by 32, since there's 32 threads in that inch space. Works out to a 32nd, and we're going to go times, we're just for safety going to say 5. Okay, so that's 156 thousandths. So on this breakthrough depth, we're going to put that number. Okay, so it may look a little funny on our on this feature because the model doesn't have the cross hole going all the way through. But unless we're going through and doing some bottoming tapping and have already cut this hole coming in from the side, we just have to cut deeper. Okay, so that isn't going to be fully threaded. That is just the clearance for the bottom of the hole. Now we're going to go over to cycle. We are going to do the deep drilling cycle, and I've had a few questions on why we're doing this. Just because it's soft material doesn't mean you can plunge straight in. If you plunge straight in aluminum, it does what's called galling. Galling is where the aluminum smashes against aluminum and almost re-welds to itself. So you want to have these short pecks with a fast retract that pulls the chip out of the hole and flings it off. So to do that, that's why we use this deep drilling cycle even if we're not going very deep. Current pecks are set at default at 44 thousandths. Let's go 60 on that. And then we don't need any dwells or anything, so we're going to leave that all at default there. Let's hit OK. Okay, so we're going to go to drilling. We're going to select from our UMC library the 1032 tap, which should be tool number 14. All right, we're going to select our tool orientation, face, and x-axis. We're going to select our two holes. And then on our heights, we're going to leave everything at default except for this whole bottom. We're going to go negative let's go 4 thread pitches. So remember, it's a 30-second. So 1 divided by 32, which is a 30-second. We're going to go times 4 this time, is an 1/8 inch deeper, 0.125. And we need to make sure that's a negative number, so it goes deeper. And that'll make sure we get a fully formed thread. Now we go to our cycle. We're going to leave that alone and hit OK. Okay, so we're at 2 threaded holes. Now the last feature. We're going to attempt to cut this face here on the model that I have highlighted with a 1/4 inch end mill. Okay, so we're going to go to 2D contour, and we're going to select the 1/4 inch end mill we've been using. We're going to keep the default settings here. On multi-axis, we're going to select the tool orientation. And what we want is for it to come in at this angle, so it'll rotate the table up, and we're going to take a cut. Okay, so what we're going to do is we're going to do a contour along this edge. So we're going to go 2D contour, and we're going to select our 1/4 inch end mill that we've been using in this document already. And select, we're going to go to the Axis tab. In our tool orientation, we're going to use Z and Y plane because we don't have a good X-axis plane to select on. And instead of selecting a plane, we're actually going to select the edge we want vertical. And then we want to select our Y-axis, which is going to be this edge or this edge. It doesn't really matter which one. And we want to flip our Y-axis because we want it facing away from us. And then we're going to go to geometry. Now in geometry, we're going to switch to chain, but we're going to do an open chain. And we're going to select the bottom edge of our cut. So the machine will rotate so that the spindle is normal to this line here. And then we can just do a traditional profile cut. Now we could use swarf on there. Swarf is really more intended for it to follow a curved path instead of a single straight line. But you can do this just with a 2D contour and flipping it into multi-axis mode. And our heights, we're going to just leave everything at default. It'll calculate off our stock volume, give us some extra cushion. And then our bottom height is going to go right to that edge I selected. I'm going to go negative 0.005, it's not very much, or 5 thousandths, a little bit deeper, just to make sure we're getting past tendency. All right, and then we're going to go to our passes tab. We're going to, again, change the default to wear. We are going to do roughing passes. Let's do a maximum step over 0.125. 1 step over at the bottom. We are going to do multiple depths. Again, 0.125. We're going conservative on our cuts. And 0.01 or 10 thousandths for finishing step down. And up here at our step over finish is going to be 0.01. We're going to rough it. We're going to finish it only at final depth. We're going to rough our final. We're going to use ease and step downs, and we're going to get rid of our islands. We're not going to leave any stock to leave. We don't need smoothing on. Go to linking tab. We are going to come in at a sweep angle of 0, and our linear lead-in distance is going to be 300 thousandths, a little bit more than half the diameter. We don't want to arc in because we could hit our vise, and so we want to come in just straight. And let's get rid of our vertical lead-in radius, and let's see what we get. Okay, so we get our cuts, and we're going to get a little V shape, and we are going to get pretty thin right here. That's why we're doing this absolutely last. And again, this is a disadvantage of using your origin on your stock, because if your stock was cut too short, this little V shape starts shifting closer and closer to your vise. Okay, we'll be running the proven program, so cross your fingers. All right, on the third operation for this project, you are going to figure it out. All you have to do is put it in a vise and face the back off. I am not doing a video for that, and you can handle it. So that should be the last of the operations. Again, you're going to have a third operation, which is going back to a VF1. To deck off the back, even though I didn't do it in the video, you need to submit 3 setup sheets and 3 post-processed files. Okay, I hope this works for you, and this is the last component I think we'll be making in the class, so you can put your assembly together with the spring and the hardware we have and the shaft, and it'll all come together, and you'll have an indicator holder you can take home.